Now, aponeuroses are really important. They're just like a tendon, like your biceps attaches to your radius in your arm, with a very thin and quite strong tendon. But for these anterior lateral abdominal wall muscles, the tendon is very flat and forms a kind of fibrous sheath. And these are known as aponeuroses. And these aponeuroses form what's called the rectus sheath. And on the body plan, we can remember that we've got the midline running down here, and then we've got our semilunar lines. Remember those semilunar lines from the surface anatomy talk? Well, these semilunar lines form the lateral boundary of a structure known as the rectus sheath. We can see them here where we've got the midline, and we can make out the indentations of rectus abdominis, and then we have the semilunar lines here. And these form the boundaries of what's known as the rectus sheath. This is formed by the aponeuroses from these muscles coming around and interdigitating around rectus abdominis to unite in the midline. And we can see this here. Now, this is a particularly complicated image, so I'll have to take some time in explaining it. But what we can see is a transverse section through the abdomen. So it's like someone's just chopped me in half, and you're looking down onto the cut surface. So we can see what we have is the posterior aspect, which is down here. So this is at your back. And then here, this is anteriorly here. So that's where your umbilicus is. This is in the midline here. So this is where your linea alba is going to be located. And what we have radiating from the posterior aspect are these anterolateral abdominal wall muscles. We can see we have three of them again. We have 1, 2, 3. We have our external oblique, internal oblique, and transverse abdominis. We've got these three muscles. But what you notice is the actual muscle tissue, which is here in orange, doesn't run all the way to the midline. The musculature stops just before it gets to the rectus abdominis muscle here. So this is where we find our semilunar lines, just here. The lateral extension or the lateral boundary of the rectus sheath, of rectus abdominis muscle here. And what we find is that these aponeuroses from muscles external oblique, internal oblique, and transverse abdominis interdigitate around rectus abdominis as they pass towards the linea alba in the midline. The formation of the rectus sheath differs, and this is where above and below comes in. It differs if you're above or below the umbilicus. Now, this is the level of the umbilicus, this here. This is the umbilicus just here. So if you're above the umbilicus or if you're below the umbilicus, this arrangement is going to be different. So let's have a look. If we are above the umbilicus, we're looking at the details now of the rectus sheath above the umbilicus. And that's this one here. So imagine that this line here is coming, just like this one, coming from the posterior aspect. So it's taken higher up above the umbilicus. We're looking at the formation of the rectus sheath. We can see that here we have external oblique, here we have internal oblique, and here we have transverse abdominis. We can see that anterior, this is the rectus sheath, anteriorly we have the aponeurosis of external oblique, and posteriorly, behind rectus abdominis, we have the aponeurosis of transverse abdominis. So anteriorly to the rectus abdominis muscle, we have the aponeurosis of external oblique, and posterior to rectus abdominis, we have the aponeurosis of transverse abdominis. So what happens to internal oblique? Well, the internal oblique muscle, as it approaches rectus abdominis, splits into two. So the aponeurosis of internal oblique splits into two lamina, an anterior lamina and a posterior lamina. So we have the anterior layer of internal oblique aponeurosis. Posteriorly, behind rectus abdominis, internal oblique sends a layer that goes behind rectus abdominis. So posterior, we have the posterior layer of internal oblique aponeurosis. So if we were to go from anterior to posterior, we'd find the aponeurosis of external oblique. We'd then find the anterior lamina, or the anterior layer of internal oblique. We'd then find rectus abdominis. Carrying on posterior, we'd then have the posterior lamina, or layer, of internal oblique. And then we'd have the aponeurosis of transversus abdominis. So effectively, we'd have 1.5 anteriorly and 1.5 posteriorly, where the two halves have come from internal oblique dividing. And then most posterior, we then have a fine layer, which is called transversalis fascia, and then we have the peritoneum. We'll explore those in later classes, in later lectures. So that's above the umbilicus. If we now go below the umbilicus, then this is a lot simpler. So previously we had the section above, and now we've made a section below the umbilicus. So now we're concentrating on this one. Similar orientation of muscles. Here we've got rectus abdominis radiating around here. We're imagining that this is attaching to the posterior wall again. So a similar arrangement. But this time, the aponeurosis from all 3 anterolateral abdominal wall muscles, all 3, external oblique, internal oblique, transverse abdominis, runs anteriorly. Internal oblique doesn't split, and transverse abdominis aponeurosis passes anterior to rectus abdominis. So the only thing we have posterior to rectus abdominis is that membrane I spoke about, transversalis fascia, and then the peritoneum. We can see it here. External oblique, internal oblique, transverse abdominis. We can see that the aponeuroses from these muscles all pass anterior to rectus abdominis. So we can see that above and below the umbilicus, the rectus sheath is very different. Above it, internal oblique is divided. A lamina goes anterior and a lamina goes posterior. And below the umbilicus, all 3 aponeuroses pass anterior to rectus abdominis to then merge with the linea alba. So that's the rectus sheath. It's very, very important arrangement.